Okay, 700 joules of work to pull a stubborn dog Cujo across the ground. Cujo has a mass of 55 kilograms and was initially at rest. What's his final velocity? Okay, so the obvious starting point here is it's talking about work. And so that kind of gives me a little bit of some guidance of where to get going. So here's, here we go. Here's Cujo. Oh yeah. Totally what he looks like. We're doing work on him, 700 joules of work. And we're causing him to kind of be moved some distance. And at that point, he's going to have some velocity that we don't know what it is. All right, so just going with the numbers here, let's just see if we can get down what we have. We've got a mass of 55 kilograms for the dog. We've got a work done of 700 joules. And we have starting at rest, so initial velocity is 0. And we end up at some final velocity. We're not sure what it is. So as soon as I see work, the little light in my head goes off. Okay, I say, okay, work, that's a big thing. That's something we did. So I'm looking at my work, power, and energy unit, and I'm saying to myself, okay, there's 3 equations that have work. There's this one, work is force times distance, which is the definition for work. There's this one, which is power, work over time. And there's this one. Well, this one looks confusing, but really it's just your energy final minus your energy initial, so total energy added up. Energy added up, final minus initial, which is delta E. So really, this is the equation. W equals delta E. That's really the equation. Okay, so either we have work causes an energy change, or we've got power is work over time, or we've got work is force applied over a distance. So I ask myself and say, well, which one is this? Well, it's clearly not power. It doesn't ask about power. It doesn't give time, so it's not power. So it's either work being done to move an object a distance or work causing an energy change. Well, the dog is definitely moving a distance. He would have to for this to happen. But it doesn't tell me anything about the distance. It also doesn't say anything about force applied, even though I know there's a force applied. But it doesn't say anything about force. It doesn't say anything about distance. So this equation is not going to help me. So I'm going to have to do this work equals change in energy. So when I'm thinking about it, I'm thinking about there being 2 different types of energy, kinetic and potential. So I'm thinking about what types of energy does the dog have. Potential energy is stored energy. Kinetic energy is motion energy. Okay, so I'm thinking about these 4 types of energy here. I'm thinking about the stored energy the dog has initially, the kinetic energy the dog has initially, the stored energy the dog has finally, and the stored kinetic energy the dog has finally. Okay, just as a recap, potential and kinetic energy. Potential is stored energy, usually because of gravity. Kinetic energy is motion energy based off of the object's velocity. So, without even doing any math, I'm just going to ask myself, does the dog have an initial stored energy? Well, no, he's just sitting there on the ground. So he doesn't have initial stored energy, okay? So this is 0. Does he have the initial kinetic energy? Does he have any motion energy at the beginning? No, he's at rest, so that's 0. Does he have any potential energy at the end? Any stored energy at the end? Well, no, he's just on the ground moving, but that's not stored energy, so that's 0. Does he have any motion energy at the end? Yes, he's going to be moving. He's going to have some speed, so he's going to have some final kinetic energy. Okay, so now I'm looking at this, and I'm like, all right, this work equals change in energy. That's going to be, I'm going to be able to do something with that because I have an energy change. I've got 0 energy changing to having kinetic energy. Okay? So here's the equation. work equals KEF plus PEF minus KEI plus PEI. Okay, work 700, that's what I got from over here. So 700 equals final kinetic energy. Okay, I don't know what that is, so I need to figure it out. Okay, I'm going to do that over here. KEF equals 1/2 times the mass times the velocity squared. I don't know how fast Cujo is going, so I just write VF squared. Half of 55 is 22.5. Plus the potential final, which was 0, minus kinetic initial, which was 0, plus potential initial, which was 0. You end up with this. 700 equals 22.5 VF squared. Divide the 22.5 over. You get VF squared equals 31.1. Square root both sides to get just VF. And you get 5.58. Okay. All right. Questions on that one? Anything you need me to explain, talk about, go over, clarify for that one? Okay. Perfect. All right. Next one I want to do here. Let's see. We did 28. Okay, let's do 30.